would data structures be? What is your idea? What exactly is anyone? Data
Data
structures.
structure proper way of arranging data so we can manipulate it easily.
Yeah, you are really not audible. I could not really follow anything what you said. Anyone can hear what he is saying?
Sir, it is a method by which we represent different.
Hello?
Yes, can you hear me, sir?
Yes, sir.
Yes, now I can hear you.
Sir, it is a method for representation of data.
It is a method.
Of
I'm sorry, you either is it a network issue on my end or is this a are you
No, sir,
but
are
I
we are,
can hear you,
is
sir.
everyone
sir, we can hear him.
Yes, sir.
okay? All right. So this is Uddipan, right? Uddipan was trying to say
So
you are
data
not
structure is used for to store the data efficiently.
exactly. Exactly. So data structures is not just about collection of data, but it is rather organize data in a most efficient manner. So when we speak about this efficiency, there must be some way of measuring this. I mean, efficient way. This one is not an efficient way, but there has to be some way of measuring this thing. So that is what we first need the subject of data structures. And that is the concept of analysis of any sort of algorithm. Data structures also has another part of the subject, which is data structures and algorithms. So the first part is we have to deal with algorithms. So for that, it's something like this.
One thing you tell
Say
me
you
that
love
this
collecting
is the
books.
circuit.
Say
Okay. Here you see load resistance.
say Emily loves collecting books. She loves reading books and she loves collecting books. And she has in her home entire completely which has been converted into a bookshelf, and she has got hundreds of books over there, books on all sorts of subjects. But the thing is that Emily, and every time she has got a new book, she has just placed it in the bookshelf. Now one fine day a friend of hers, Bhargav, comes along and asks Emily, do you have this one particular book? And Emily says, yes, of course I have that book. And Bhargav asks, but now the problem is that since Emily has gradually built up her collection, she has just placed those books randomly in. So to find one particular book inside that bookshelf where everything has been stored randomly, it is going to take a huge lot of time. Structures is all about how efficiently we are going to store these particular data. So if instead of randomly storing in the bookshelf, she would have at least allotted specific space, specific areas for the books, for areas. Then the searching process would become much more easier. The book reduces down. So as soon as the area in which she has to find the book reduces, the total time total number of books to go through, if it is reducing, then the total time is going to reduce also. And the more and more subdivision that Emily can is going to be for her to find that one particular book. So data structures is all about something like this. How efficiently your data. So this can have say this time taken to find one particular shelf, there can be specific cases. What can be the best case? The best case is that she looks at the bookshelf out right at the very beginning. The book that she's searching for just catches her eye. The book that she's searching for just catches her eye. That's the best possible situation. So best possible situations don't really occur all the time. What's the worst possible situation? The worst goes through all the books in that particular section. See, even if she has done the entire subdivisioning, she has to look for the book in this one. There are, say, 50 books in here, and she has gone through all 50 books, and only in the last instance does she find that particular book. There can be a best case scenario, a worst case scenario, and an average case scenario. The time we could find out of your entire data set. So that I would like to represent. What do I mean by this? This, say, example is, suppose you guys have all cleared grade cards. Say we have this big pile of grade cards, and these grade cards have been, say, this is not what I'm saying right now, but your class teacher takes these grade cards to you guys when we resume our physical classes, that is, we class grade cards and goes to your class, comes it on the table. So you have to find your particular grade card. But send us the grade cards, they have just arranged them in random haphazard order. So they have been arranged in random haphazard order, and particular person has to find his or her grade card. Then what's the process? You would just pick up one grade card after another after another. You would check aside, is this my grade card? No, move it aside. That way you would keep on going through the grade cards to find your one. What's the best case? What's the best scenario? Lying absolutely on the top of the pile. First one you pick up, that is your grade card. Found it. What's the worst case scenario? What's the worst possibility? Absolute bottom of the pile. It's lying absolutely at the bottom of the pile. You have started at the top of the pile, and you have no idea that your grade card is there at the all the grade cards in the entire pile, and you find yours at the absolute last position. So from a time complexity is possible. Okay, now this time let's go through a slightly different situation. This time the grade card random haphazard situation, but rather they are available in a complete like organized manner. In row they are arranged, and you have to find. So you know your roll number. Say your roll number is 11. So you know that these are arranged in roll number wise order. My roll number is 11. So my grade card is going to be near the top of the pile. So you cannot bunch of it like that. You have to take up one at a time. So you start picking up grade cards one at a time. You come to roll number 11. You pick up your grade card. What would be the worst case situation? The worst case situation, if your roll number is, say, what's the strength of this batch? Say 70, right? 79. Okay, let's say, for example, 80. So what's the worst case situation? Worst case situation is your roll number is 40. So roll number is 40 means middle of the stack. So, and you are not allowed to pick up an entire bunch of grade cards. You have to go through one by one by one. So worst possible situation, 39 grade cards before you come to your particular grade card, roll number 40. So First case situation becomes order of log of. What do we mean by this order of situation? That we'll get to. Now, another possibility, this time, your class teacher is calling up two people at a time. Class teacher is calling up two people at a time. The pile has been split up into two pieces. If the pieces okay, so now we are calling up, say, two students at a time are being called up, and they are being asked to find their grade cards. Now, these two guys are obviously very good friends. So, again, let's say Emily and Bhargav, both of them have come up, and now they are looking for their grade cards. So the entire pile, and Emily is not just looking for her own grade card; she's also looking for the grade card of Bhargav. Same thing with Bhargav. Bhargav is looking for his grade card and also the grade card of. And if we can multitask, if we can split up the thing into parallel processing, then obviously much faster. So worst case situation in the earlier one was n, whereas this one, the worst case situation is going to be n by 2. In random haphazard order, since the size of the pile only has been made into half, the worst case situation is n by 2. So if you are going process of parallel processing, then of course everything becomes much faster. But it's not always possible to apply. Sometimes you might be restricted by, say, hardware or software or whatever. In some way or the other, the concept of parallel processing. Just one second. Yes, very sorry about that. Actually, today there's an award ceremony which is going on here in college. So all your batchmates and all are, two of the students had come to say hello. Right. So sometimes parallel processing is not really possible. So in that, data structures is a way around in these particular situations. So data structures is a process in which we data in such a manner that we don't need to rely on parallel processing. We can store the data in an organized manner so that we, for all these and searching or sorting or whatever process. So now translating programming language logic, translating this to our programming language logic, let's take a look at a very common algorithm, which is the factorial of any number. To calculate the factorial of any number, we have two different algorithms. We can essentially two types of algorithms. Can anyone tell me what are the types of algorithms that we can use to calculate the factorial of a number? Anyone?
Sir, can you repeat?
I am audible, right? Hello?
Yes, sir, you
Yes,
are audible.
sir, we can hear you.
Yes, so I am asking you guys, there are essentially two algorithms that we can apply to calculate the factorial of a number. What are sure that you guys have done these things previously? So two types of algorithms to calculate factorial of a number.
Sir, first one is normal function, recursive function.
Normal
Sir, the function which calls by itself.
Yes, what's that called as?
Sir, I am forgetting the name.
No,
Sir,
that is recursive.
No, not at all.
something starting with R, sir. R only.
Yes. Process called as when a function calls itself.
Sir, recursive.
Recursive.
Yes. Yeah. So one way is we can apply the recursive algorithm, which is this one. Where I am calling where iteratively from within the function. So a function is calling itself. That is a recursive algorithm. And the other is a normal iterative algorithm. So iterative process and recursive process. These are the two processes which you can the factorial of any number. So this one requirement only, the one requirement calculation of factorial can be done either with the iterative algorithm or with the recursive algorithm. So then the question becomes, one is better? Which one of these two algorithms is better? Is it better to apply the iterative process or is it better to apply the how do we calculate that? How do we find that out? Now, one way in which we can do that is I can run the same computer. I run both the algorithms on my computer and I give it say different data. So say I give it say 10 values I give to the iterative algorithm. Those same 10 values I give to the recursive algorithm. And every time much time is being taken by these algorithms to calculate the result. And out of those 10 times, I come up with an average time taken algorithms. Out of those 10, I come up with an average time taken by the recursive algorithm. And then I can say that, okay, so this algorithm is better. This entire task is definitely very cumbersome. And very frankly, this is a very stupid way of solving the problem. There has to be some better ways in which we can calculate the time taken or time complexity of, and that is given to us by what is known as the big O notation. The big O notation, it helps us to calculate space complexity of any algorithm. So big O notation is sort of the measure of the upper bound of algorithm. What's the maximum time that this algorithm can take? Okay, so there are different big O values. So the big O values from in order of their performance are shown over here. So order of 1 meaning takes 1 unit of time. So when I'm saying order of 1, it means it takes 1 unit of time. Irrespective of the size, it takes 1 unit of time to calculate the result or to show us the result. Order of log n means it logarithmic value of time to calculate the result depending on the size of the data set which is being provided to. N is linear. Order of n log n is a combination of linear and logarithmic. Order of n square. Now we are starting to get into. So from best possibility to worst case situations. So order of 2 to the power n is an algorithm to take a huge amount of time. It takes a huge amount of time to sort through data and produce a result. Where do I apply which particular order? Or where do I apply which sort of an algorithm? Again, sort of a story. So imagine that in a classroom of 100 students, I am playing a game, a pen to one particular student. I have given a pen to one particular student before the start of the class. And I have told hide the pen. I told him to hide the pen. He can either hide it with himself or he can hide it in the bag of say someone else. He knows where he has hidden that particular pen. So,
Sir, he's fake.
hmm?
Sir, he's fake.
Who's Lamna? He will be, oh, the person who has just. So apparently this thing is going on with your batch for quite some time.
No, sir, no. He is real. Uddipon Chaudhary is real, but Uddipon Sarkar who came is not real.
Yes, sir. Yes, sir.
Yes, well, anyway, if some disturbing element wants to disturb the class, I really cannot. It's their wish. Just ignore them. Okay, so we were discussing that. So this one pen to this one boy, I told him to hide the pen. And either he can keep it with himself or he can hide it in the. He knows where he has hidden it. Now, in the middle of the class, I asked him, now I want to find that particular pen. Two approaches that I can take. And these different approaches are based on different conditions. So the condition where I have given the student and told him to hide the pen, and only he knows where the pen is hidden. No one else knows. So in that particular, how do I find it out? I go to say, I pick up roll number 1 and I ask him, do you have the pen? No, sir. Okay. That's roll. No, sir. Roll number 3? No, sir. Roll number 4? No, sir. Roll number 5? Yes, sir. Okay. So that way, I am asking the first, not just himself, but also about fake person. Right. So what happens is, so I'm going to each and every person, and I'm asking him not just about him, whether he has that all the other 99 people. So this would be n squared times, so 100 people into going through the process of asking for the particular pen. This is a very cumbersome task, but I have to do it because only one that pen is hidden. No one else knows where it is hidden. Okay. Now, case number 2 is I have hidden the pen with he knows where it is. he has given it to someone else. He also knows who. The other person also knows. The other person also knows. So in this particular situation, I can just go to the 100 people. I can just go to the 100 people and ask them, do you have the pen? A yes or no question. If he has the pen, then he will give that. So this reduces the complexity by a lot. So from a quadratic to a linear situation. Another possibility is I have given the pen to be hidden. Now everyone in the class where the pen is hidden. So in that case, the best approach that I can take is I can divide the entire class into two halves and I can ask is on the left hand side. So people say, sir, it's on the right hand side. Okay. So I completely reject the left side, meaning I reject. Now I concentrate on these 50 people. I again split it up into 25, 25. And I ask, is it again on the right hand side or on the left hand side? Splitting the entire group into halves until I find the one person where the pen is hidden. So this is a logarithmic order is where every time I am splitting up the size of my the size of the data set. Every time I am reducing the size of the data set by half. Now, if I want to visual, okay, so this is something that we already studied. N square is a selection search algorithm. N square, order of n square, is a selection search algorithm. These are the common searching algorithms. I'm sure that those of you who have studied programming before, you have gone through the searching and sorting algorithms. In fact, in your first year also, you have gone through searching and sorting algorithms. Have you all not? Has it been covered with you guys, searching and sorting algorithms? Yes, wonderful. So selection search, linear search, binary search, I'm sure that these have already been covered with you guys.
Sir, this was done, but it was in a very fast way.
Sir, this was not done in our section.
This was
Not done in our section.
not done in your section. Okay. Okay. So yeah, I guess it was with different sections. You guys have had different stuff going on. So okay, take it. So this is sort of a revision also.
Sir, can you re-explain the first and the second?
So these are common searching algorithms. These are very common set specific types of searching algorithms. So a selection searching algorithm usually follows the quadratic order. It follows the order of n square. Linear searching algorithm follows order of n. And binary searching algorithm follows the order of log n. So clearly, binary searching algorithm is much better than a selection searching algorithm. Okay. So if I want to find data in the fastest time possible, I would always prefer to use a binary search algorithm. So a visual representation of these different orders, a visual representation of these different orders. So anything in red, those are horrible when it comes to time complexity. Those are horrible in nature. So as the is along my x-axis, total number of operations which are being carried out, which is directly proportional to the total number of time, total amount increases exponentially like this. Okay, so anything in this red category, those are horrible sorts of situations. It is horrible, but it is that we are forced to apply those particular algorithms. Sometimes it might happen that even in a situation, an algorithm which can do the job in a much faster way. So in that case, if I'm applying the bad algorithm, that's on me. Right? We should know all sorts of algorithms when we study these areas.
Sir,
In fact,
মুঝে ও n স্কয়ারটা আরেকবার বলতে পারবেন?
order of n square. Order of n square is that. So in this example, I am asking roll number 1 about all the 99 other people. Then I'm going to roll number 2 about all the other 99 people. I'm asking roll number 3 about all the other 99 people. So I'm asking all the other people. That means I'm asking one person about n people, and I'm repeating this task n number of times. So n squared times. So how does this translate into our programming? How does it translate into a program? I'll show that to you very soon. How does that translate into a programming situation? So, right. Different data structure elements and a comparison of the time complexity dealing with those data structure elements. So arrays, we are already very familiar with. Arrays we have dealt with previously. I want to access an array. It takes 1 unit of time. 1 unit of time to access the array. If I want to access one specific data element, it is always going to take 1 unit of time, irrespective of the size of the array. Be the array has 10 elements, or if the array has 1000 elements. If I want to access, say, the 10th element in the array, it is always just because the array size is 1000, it does not mean it is going to take a larger amount of time to access the. So for an array, accessing of data is very fast. But array has got other sort of disadvantages. All these other data structures exist. Otherwise, array only would have done the job. So we will go through the disadvantages of arrays as well. Search an element. If I want to find the position of an element, the normal finding process, the normal algorithm, if applied on an array, it would take the order of n. You can, of course, apply the binary search algorithm. In that case, it is going to take order of log n. Right? So order of log n is a better situation, much better situation than order of n. Order of log n is over here, much better situation. If I want to say insert an element into an array, I say that I want to insert an element in array, I'm trying to say that there already are elements in the array. So say I have size 10 and there are 5 elements in the array. I want to insert a new data in, say, the second. Insert one data in the second position. That means I have to shift everything else. I have to shift everything else to make space for that new data. Insertion process is going to take order of n. Say, similarly, if I want to delete one particular data element, it's going to take order of n. These are your average time situations. Similarly, there is this entire table also shows us what is the worst case of these algorithms as well. And in majority of the cases, you will find that as you go into the more and more advanced structures, you will find that the worst possible time is similar to the average time. Why so? Because these data structures are more efficiently. These data structures have been built in such an efficient manner that the worst possible timing taken is the average time. Worst case. There is no worst case. Okay, that is how we improve the efficiency. So now these are some search or sort algorithms. These are sort algorithms and the time complexities of these sorting algorithms. Single view of the entire. Okay, now next we come to your question as to how does translate into programming. So how does order situation translate into our programming? Well, general statement. So by general statement, what do I mean? By general statement, I mean a conditional statement or so I'm storing a data into any particular, say int n equals to 5. This is going to take 1 unit of time. The size of the entire program, int n equals to 5 is going to take 1 unit of time. It's a constant time. One single loop. If there is one single loop, then it is a linear situation. So is a linear situation. One nested for loop, where there is a for loop inside of another for loop, this is a quadratic situation. This is order of n square. Okay, so you were asking to explain situation of order of n square. So we would face order of n square if we, in our program, we are applying a nested for loop. Are having a nested for loop, then that is going to take order of n square. Now, the binary algorithm, I'm splitting the process into half and splitting up my data set from the middle point. That is order of log n. In this, splitting it into two pieces, and I'm not just splitting it into two pieces. I'm splitting it into two pieces and eliminating, concentrating only on the other half. I'm reducing the size of the data set by 2 in every step. That is the logarithmic time. Particular algorithm where I'm using the quick sort algorithm. Quick sort algorithm is n into log n. Quick sort algorithm up into two pieces, into two halves, yes, but there is a one loop. There is one loop which is going to run n number of times. An order of order of n, and the splitting it up into halves is going to have an order of log n. So in total, n into log n amount of time. So these are some examples where, from the program perspective, as to how much amount of time the algorithm is going to take, what is going to be the order of that particular algorithm. Okay. Clear till now? Is everything for everyone till now?
Yes, sir.
Anyone having any sort of doubts, any questions? Anyone? Okay, so from your silence, I'm going to assume that. So next we go into arrays. That's a trick. I think we have run out of time today. So the next class that I have with Thursday, we are going to get into basics of arrays. We have you guys have already done arrays before, so just again of arrays, and then we are going to move further into some of the disadvantages of array and how other those problems. Okay, so okay, that's it for today. I will stop it over here, and yeah, I will share the attendance link with you guys. Yes.
Sir, if someone of a for loop, তাহলে আমরা বলবো big O n, মানে আমরা কি মানে কি সবসময় কি worst case টা ধরে নিতে হয়?
Yes. for loop is running 10 times, if a for loop is running 10 times, আর সেই লুপটা একটা 10 মিলিসেকেন্ড টাইম লাগে, তো তার মানে 10 বার রান হলে কত টাইম লাগবে? প্রত্যেকবার 10 মিলিসেকেন্ড করে লাগবে। সো আমার যদি ফর লুপের সাইজটা যদি ফিক্স থাকে, যে ফর লুপটা 10 বার রান করবে, তাহলে আমার
হ্যাঁ
সবসময়তেই আমার ওটা যে ওয়ার্স্ট কেস সিচুয়েশন হচ্ছে তার কিন্তু কোনো মানে নেই। হ্যাঁ, এবার এখানেতে ওয়ার্স্ট কেস বা আসতে পারে যদি ফর লুপের ভেতরেতে আমার একটা কোনো কন্ডিশনাল স্টেটমেন্ট দেওয়া আছে, যেখানটা করে লাইক ফর এক্সাম্পল ইউর সার্চিং অ্যালগোরিদম, what do? We go through the entire data set, but as soon as we have found what we are looking for, then এগুলো আর করার প্রয়োজন হয় না। Say I'm looking for a data element and that data element is in the 5th position. The size of the array was প্রথম 4 বার ফর লুপটা আইটারেট করলো, 5 নম্বর বার আইটারেশনের টাইমে since I found my data, in that case I can just display the data and I can exit from the for loop, then আমার আর বাকি 15 খানা এক্সিকিউশন লাগলো না, তো বাকি টাইমটা আর প্রয়োজন হচ্ছে না। ঠিক আছে, সো দ্যাট the best case and worst case and average time situation. What would be the best case if the data absolutely at the first position, at the 0th index position? ঠিক আছে?
ইয়েস স্যার।
Okay. I will see you all again on Thursday. I've given you guys on the chat box, I've given you the attendance link. Thank you guys. I'll see you all again on Thursday.
থ্যাংক ইউ স্যার।
Thank you, sir.
Thank you everyone.